This will be our lesson on y equals cosine of x, the parent function. As it is going to be our first time on cosine of x, where we'll sketch the unit circle to see where some of the values are coming from, as well as the table of values. I am currently on page 13 of the Unit 13 packet. So over on the right, let's go ahead and come up with a circle. And then if you guys can label the quadrantal values. So in this case at 0 degrees, for example, it's 1, 0, 0, 1, negative 1, 0, 0, negative 1. And then also create a table of values. We'll call the angle measure theta, and then the output y equals cosine of theta. So as you recall doing this, we're going to have 5 key values: 0, pi over 2, pi, 3 pi over 2, and 2 pi for the angle measures. At 0, we want to ask ourselves, what is the x value at 0? And so when we're looking at these values, we're looking at these x values that you see here. And so the first one would be 1. The x value at 0 degrees is 1. The x value at pi over 2 would be 0. At pi, negative 1, 3 pi over 2, 0. And then back at 2 pi, we have 1. Let's go ahead and plot these and recall that we can keep going with this and we can get 5 pi over 2. I'm going to stop here, but we can get 5 pi over 2. We can get 3 pi, what 3 pi is equal to if we wanted to, and we can keep going because there's an infinite number of angle measures that we can plug in. So because I see that my highest y value is 1 and my lowest is negative 1, I don't need my y-axis to go all the way up to 6. So let's go ahead and change these y values to be 1, 2, 3, negative 1, negative 2, and negative 3. And then down bottom, let's go ahead and practice labeling the angle measures, because on some of your homework assignments you'll just have a sheet of graph paper and be expected to know the angle measures at which you're doing it. So if we do which we have the 5 key points. So if we start here at 0, currently there's nothing affecting the period. So the 5 key points that you would have is at 0, angle pi over 2, angle pi, 3 pi over 2, and 2 pi. So as I'm plotting the points, my first coordinate point that I'm plotting is 0, 1. So let's go ahead and plot 0, 1. At pi over 2, we come down to 0. At pi, we have negative 1. At 3 pi over 2, 0. And then at 2 pi, we have 1. So we see that to complete one cycle of the cosine graph, we get what looks to be a V/U looking shape. But that's going to be your first wave of the cosine function. And I'll switch colors. This is all part of the same graph, but I want you to see in a different color that this function continues to go to the right to infinity and then to the left to negative infinity. But the pink is to designate that's one full cycle and one period of the cosine graph. After that, it'll start to repeat itself. So if I were to continue in that same pattern, this next angle measure, which I'm going to help you guys come up with, is it would be down below here. We're repeating the pattern that we see over on the left-hand side, then one here, then one back up. And so that would be here another cycle of the graph. And then again, with same as the sine graph, we can go negative revolutions on the unit circle. So there are negative y values, negative angle measures. So negative pi over 2 on this side, negative pi. So one of the questions you might be asking is, how do I come up with the angle measures to the right of 2 pi? So if I take a look at my unit of measure, it's the same as if you guys were counting by a half of something. So we have 1/2 a pi. Then this is really, and let me just mark this in a different color. Pi is the same thing as when you get to pi, you have 2 pi over 2. Then the next one is 3, and 2 pi over 2 reduces to pi. Then you have 3 pi over 2. Then this is really the same thing as 4 pi over 2, which reduces to 2 pi. So what would this angle be? If I counted 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, that would make sense that it's 5 pi over 2. The next one would be 6 pi over 2, which reduces to 3 pi. Then the next one would be 7 pi over 2, and so on and so forth. And so sometimes if I ask that you label your x-axis and you graph 2 cycles, that's what it would look like. The domain of the cosine graph, if we assume that this goes on to infinity and negative infinity on left and right side, then the domain would be negative infinity to infinity. The range would be the highest and the lowest value. It would be -1 to 1, so same as the sine function. And the period for this would be, we complete one period with the pink outline that you see of the graph, which is 2 pi, with the length of 2 pi. And the max is 1, the min is -1. The distance between the midline and the max, or the midline and the min, is 1. So these graphs are what we call the sinusoidal graphs. They are the sine graphs and the cosine graphs. So what you guys saw before on the sine graph and then up above there, these are the parent graphs of the sine and cosine function. So what happens after that is what is similar to what had happened with our other functions. There's variations on it where you guys have now y equals capital A for amplitude, sine of x, sine of bx, and then capital A for amplitude, cosine of bx. So these values, A and B, that you see let me re-highlight that in green, this A and this B value are going to affect our amplitude, or how high our graphs are going to get stretched, as well as the period length, either being stretched horizontally wider or more narrow. So on the first part, the capital A is going to stand for amplitude, and that's going to be how high our sine and cosine graphs. It'll dictate how high or low our sine or cosine graph will be for the max and the min. The period would be something that we would calculate using the B value. So the period is equal to what the normal period would be, which is 2 pi, divided by that B value that you see inside next to the x. Okay, if A is less than 0, think of what happens if you have a negative in front of any function, like a negative in front of x squared. It means it gets reflected. So or I could say reflected across the x-axis, but that's the same thing in this case as being reflected over the midline. Okay, so to determine the, so what we would do to graph functions that have some type of adjustment to the amplitude of the period is to first calculate those values. So determine what the amplitude is, the absolute value of the number that you see in front of sine or cosine. Then calculate the period by taking 2 pi divided by b. And if I need 5 key points, what that's going to mean is I need to divide my graphs into quarters. So I'm going to show you what that means up above here. I'm going to highlight and then I'll eventually erase this. But if you look at my pink graph, I've divided it into quarters where I have 4 quarters to make the full cycle. So in what you need to do is figure out what your period is and then divide that by a fourth, or so I figure out my period. This is the calculation from above. And then I want to know what I want to jump by. So in order to have the graph split into quarters, so times by a fourth. And we'll demonstrate that in the next few examples. Okay, and then we're always going to have 5 key points. Remember that if you have A is less than 0, that means a reflection across the midline. And always, if you have Desmos or if you have a graphing calculator, go ahead and double check your answers. Most cases, we're going to be in terms of radians unless I state otherwise, but make sure you guys have your mode on your graphing calculator in Desmos set to radians. All right, so we're going to go ahead and